Hello and welcome. Today we will see the last problem related to the cables. The question is as follows, or the problem is as follows. Determine the tension in various segments of the cables shown in the figure. Also determine the diameter of the dia of the cable required if allowable stress in the cable material is 150 Newton per mm square. Okay. So that's what the question they are given, and the diagram is as follows. Here the black ink indicates that will be the question what they are given. Okay, and reading I considered these values we have to find out. Okay, and even the blue ink will indicates the dimensions that they are given in the question. Okay, see here, this is the figure what they are given. So in order to find out the reactions, we considered at point A VA and at point B it is HA, and at point A only vertical horizontal reaction, at point B vertical and horizontal reaction. This will be our first step to find out the forces in various segments. Okay, it's very important. Very important is here we are following the method of joint to find out the tension in the cable, that you know, so that we followed in the trusses, or even you can apply the procedure what we followed for the Lami's theorem also, even it will be holds good here. Okay, see here, in order to find out the reactions, the procedure will remains the same. So first condition, f of y is equal to 0, then we came to know HA will be equal to HB will be equal to H. Okay, directly I consider it as H. Then f of y equal to 0, VA plus VB will be equal to 300. That's what we came to know from this. Then I am considering moment at A equal to 0. Moment at A equal to 0 means these two forces will become 0. 1, 2, we have only 1 here. So 3 forces. 200 positive into 10, 100 positive into 20, minus VB into perpendicular distance is 30. That's what we followed. Then we came to know VB value is 133.33 kilonewton, VA value is 166.67 kilonewton. Then I am considering moment at C equal to 0, moment at C equal to 0 for LHS, because we know perpendicular distance here 4 meter, that's the reason. If you consider this side, you don't know the vertical distance, that will be a bit difficult. So at this time you have to follow this procedure only, f of moment at C equal to 0 for LHS, because you know the vertical distance, that's the reason. Okay, so it will be as follows. Moment at C equal to 0, then you came to know we have only C, at point C we have only two reactions. One is a horizontal H and vertical VA. VA value we know 166.67, its perpendicular distance is 10, minus of H into perpendicular distance will be 4, that will be equal to 0. Then we came to know H value as 416.67 kilonewton. Okay, after finding the reactions, here bit difficult, we have to find out tension in each segment. Either it may be A to C, C to D, D to B. These are the segments, or we can say a cable, okay, which has been supported by C as well as at point D, or we can say it is a node, or we can say it is a joint. So you have to find out member forces in each joint or in each segment. Okay, in order to find out that one, we need, here we are following the method of joints, so we need the angles here. Okay, so if it is theta 1, by using alternate angles, even it will be theta 1, or we can say z angles. Theta, if it is theta 2, even it will be theta 2. If it is theta 3, even it will be theta 3. Okay, theta 1, you know, opposite side is 4 and adjacent side is 10, so I can directly get it as 21.8 degrees. Okay, and then no doubt about here. So in order to find out theta 2, okay, we need this vertical distance, this vertical ear to ear vertical distance, that we don't know. And in order to find out theta 3 also, we need ear to ear vertical distance, even that one also we don't know. So in order to find out that one, in order to find out theta 3 as well as theta 2, so what we have to know means we have to know the vertical distance with respect to y. So for that, what I am considering? I am considering moment at d equal to 0. Moment at d equal to 0. Okay, right hand side. So we right hand side, two forces we have. Those two forces value we know, but whatever the unknown here is y only. So that is the only one unknown we have, and we have only one equation. You came to know the y value also. So that will be as follows. To find out y distance, moment at d equal to 0 for RHS, then minus of VB into 10 plus h into y, that will be equal to 0. Then y value will be 3.20 meters. Okay, that's what we have to consider, and we know from that, then we can easily find out theta 3. So in order to find out theta 3, opposite side is y, adjacent side is 10. So you can easily find out theta 3, that will be 17.74. Similarly, in order to find out theta 2, okay, we know total ear to ear it is 4 meter, then we know ear to ear it is y. So this vertical distance is 4 minus of y. So opposite side is 4 minus of y and adjacent side is 10 meter. Then this theta 2 value will be 4.70. You will get that inverse of that one. Then it will be 4.57, that we will get it for theta 2, the total value. So theta 1 we already know it one as, that one as 21.8 meter. So now we have to find out tension in each segment. So in order to find out tension in each segment, this is the procedure what we are following. So tension in each segment by using method of joints, and then by considering the method of joints, or you can say by using the procedure what we followed for the Lami's theorem, or by using equilibrium conditions we can solve. First I am considering joint C. So same figure I drawn as it is. It will be like this. The red ink indicates the forces 200 TC and tension in C2A. Tension in C2A, and we know theta 2 it is 4.57, and we know ear to ear it is 90 degree, so it will be 94.57. Similarly, we know this one is 21.8 ear to ear, then total will be 90 plus 21.8, then it will be 111.8 degrees, then 360 minus these two, then you will get it as 153.63, and we have three forces and we know angle between all the three forces. Then I can apply sine rule. So sine rule I am applying 200 divided by 200. So angle between other two forces it will be 153.63 equal to TC. Okay, this is a TC, tension in C to D. Then angle between other two forces will be 21.8. That is TCA. Sorry, TCA is this one. TCA. Angle between other two forces will be 94.53. TCD. This is the TCD. Angle between other two forces is 311.8. That what I considered. Then I am equating these two to get TCA, TCD. Okay, and this magnitude is as follows. Similarly, in order to find out another one tension force in the segment, I am considering joint D. Okay, joint D, it is as follows. Even at joint D also we have two loads. Just I am considering this one as it is. Okay, and we know if it is a force acting in a member, we have to consider that one as tension force and it is away. So we know this one is 17.74, then 90 plus 17.74, it is 107.74. Similarly, we know this is theta 2, that will be theta 2 value we got it as, theta 2 value we got that one as it is 4.57. Similarly, okay, we know this one as this is totally 90 minus of theta 2, it will be 85.43, and we know 90 plus 17.74, it is 107.74. 360 minus these two values, you will get it as 160.83. Okay, similarly now also I am applying the same rule, that is sine rule. 100 divided by sine of angle between other two forces, it is 168.32, and another one TDC, this is TDC, angle between other two forces, it is 107.74, so that is sine 107.74, that will be equal to another one force TDB, angle between other two forces is 85.43, that's what I have given here. So now I am equating these two and these two to get the value of TDC as well as TDB. Okay, these are the values what we got, and these are the tension in each segment or tension in each cable, and we know tension, that is T minimum, that will be equal to capital H, and we know H value as 416.67 kilonewton. Okay, and maximum tension value we know it is root of H square plus V square, where V is the maximum vertical load, and maximum vertical load we got for VA, that will be 166.67 kilonewton. So 166.67 square plus horizontal square, this will be the maximum tension. Okay, maximum tension we got it as, yeah, this is as follows, sorry. So this is the maximum tension, we got it as 448.76, and we know stress will be equal to T maximum divided by area of the cable, that will be pi d square by 4. Here D1 I am considering as a diameter of the cable. Then we know tension, then we know stress they are given, it is 150 Newton per mm square. Then we know T maximum, that is the value what we got it here, 448.76. This is in terms of kilonewton. I am converting this one into Newton, so I multiplied by 10 raised to 3 and pi d square by 4. In this equation D1 is unknown, so D1 will be 61.718 millimeter. Okay, if you convert that one into meter, it will be 0.0617118 meters. Okay, this is the diameter of the cable what they are given in the question. Okay, there ends your problem. Here we have to solve separately segment, that is we have, in order to find out tension in each cable, we have to divide the structure into different joints, then we have to solve to find out the tension in various segments. Okay, or even we can say tension in various cables if it is in the form of segments. Okay, there ends your module 5, that is arches and cables. In the next videos we will see module number 4, it is strain energy principles. Okay, thank you.